welcome to the Cloud Security Podcast by Google. Thanks for joining us for the first episode of 2024. Your hosts here, as ever, are myself, Tim Peacock, the Senior PM for Threat Detection on Chronicle, and Anton Chuvakin, a reformed analyst and senior staff in Google Cloud's Office of the CISO. Before I say what I always say, listeners, I just want to thank you if this is the first time you're joining us or the 154th time you're joining us. The show wouldn't be what it is without you. So thank you for joining us. You can find this show and subscribe wherever you get your podcasts, as well as at our website, cloud.google.com/podcasts. If you enjoy our content and want it delivered to you piping hot every Monday, please do hit that subscribe button. You can follow the show, argue with us, and the rest of our listeners on the Cloud Security community page. You can get the link for that in our show notes, and I am so happy that the show finally has a home for discussion and argumentation, and you should all check out the Cloud Security community. This is also a special episode because it's available as video on our YouTube channel, which will also be linked in the show notes. Anton, this episode, delightful way to start the season. We're talking to, it's hard to believe, he was an editor of Frack. He was the publisher of Smashing the Stack. He's been around the block for what feels like forever, and is now at Google doing incredible things. Like, how did this even happen? How did we get this guy?
I think that's the legendary part. And when I realized we can get this guest, no spoilers for a few more seconds, I was like, this is the season opener because this is just too incredible. And the range of topics you'd see would go from the 60s to the future, from really obscure topics of the 1990s hacking to obscure topics of LLM security. And of course, Google's scale would make an appearance. This is really exciting. I mean, we had really good season openers and good season closing episodes, of course, as you recall.
And this continues.
Yes, and this continues.
And you know what's crazy? Our next 3 episodes all could have been season openers as well. So listeners, maybe without one bit of further ado and with a teaser for the rest of the month, let's turn things over to today's guest. And with that, listeners, I'm delighted to introduce today's guest. Today, we are joined by Mike Schiffman, the Network Security UTL at Google. And listeners, if you're wondering what UTL means, I think it means he owns the future, which is a pretty cool thing to be able to say. Mike, could you tell us a little bit about yourself?
So some relevant backstory here. I am the Network Security UTL, and internally that has meaning. Externally, it doesn't. It stands for Uber Tech Lead, and in Google parlance, an Uber Tech Lead is someone who owns a particular problem domain at Google. It is not the Uber Google Network Security Liaison as people had thought in the beginning. So ostensibly, what does that mean? When I was interviewing for this role back in summer of 21, I was told by a hiring manager that this role owns the future of network security at Google. And if I wasn't all in on the effort before that, I was then. Working for Google has always been on my bucket list. And I felt like I've been training my whole life for a job like this. So once I heard that, I was like, okay, show me where the bodies are and where you want them buried. I do whatever it takes to get this job. And after nearly 2 years in the role, that simple sentence is profoundly true. I get to work on programs and drive projects that work on the near and long-term future of network security at Google.
But UTL is like, people on the inside know that the UTL is like a really, 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 really big deal. At least from my limited understanding of Googliness, that's actually kind of a big deal.
Sure. Yeah.
Okay.
Listeners, this is what you call being humble.
Yes.
Yes, that's right.
Which for Anton and I, this is a lesson. We've never encountered this before. But Anton, I'm pretty sure that was humility and we should learn from it.
Yes, I agree. I mean, this is probably useful context and humility too. So, but you have also a very fun, very, very, very fun, broader story before Google. Would you share some of the fun elements of this?
Sure. I can talk about my origin story. I do have a long history of caring about network security, so I'm going to try and keep it somewhat relevant to that, but we'll probably pull in some of the wider elements from my colorful past. So I got my start in security in the hacking scene of the mid-90s. I found most interesting at the time networking and really TCP/IP, the protocol suite that we all know and love. And at the time in the hacking scene, everyone adopted, nom de plumes. Mine that I was most well known as was route. Ostensibly after routing protocols, I guess the original context is somewhat lost on me. I also had to handle Daemon 9, which is a little cringeworthy for me, but I have no idea what the 9 was from.
It's cringeworthy for you now. Back at the time, probably sounded like really cool, right?
I guess I'd like to think so.
Were these nom de plumes or nom de guerres?
Let's go with nom de plume. So under these handles, in the mid-90s, I was also editor of Frack Magazine, a freaking and hacking digital magazine published by the hacking community for the hacking community, and still lives on today. But in the 90s, I focused a lot on writing and publishing articles that explores all sorts of sort of novel at the time network security tools and techniques and then vulnerabilities and exploits, some esoteric stuff with various TCP/IP protocols, SYN flooding, which at the time was a problem, covert channel tunneling, which was a lot of fun, and TCP session hijacking. I guess while we're on the topic of Frack, I should probably mention as a point of note, in 96, I think it was, I published Elias Levy, who is then known more colloquially as Aleph One, and he wrote the stack smashing article. And this was the seminal, still famous today article that launched the whole buffer overflow craze.
I feel like listeners, if you've heard of one famous computer security article, that's the one you've heard of. And you've probably heard security people talk about doing something for fun and profit. This is where that comes from.
Yeah. Yes, this is literally where it originated. And it's been on the minds of people for 20
years now.
How many years? Like, my math is just failing me.
A long time. Most of my life.
27, 28 years. Yeah, 27 and change probably. Something insane like that. It still applies. It still hits.
CISA just came out with guidance to adopt memory-safe languages last week.
Yeah.
They just reminded the world, hey, by the way, you should still be doing this.
Yeah, exactly. People still need to remember to terminate their strings.
Mike, maybe in your opinion, why is that advice still needed? How did we not figure this one out?
What a depressing question, by the way. What a depressing question, Tim.
Sorry.
You win the depressing question award, I think.
I'd say it's probably, well, it's easier to write code that works rather than write code that's correct a lot of times. I imagine we're also getting to the point now where you're going to have robots write a lot of the remedial code for us. So hopefully a lot of this class of vulnerabilities can stop being so much of a thing.
That would be nice.
I also have other fun stories from this era.
Yeah, please. More fun stories. Good.
Let's see. Well, one infamous story from back in that era was probably a year or so after publishing this article. So the hacking scene for me felt a lot like professional wrestling in that you had these bombastic personality types and you had people change allegiances from white-ish to gray to black pretty freely. And somebody who might have purported to be your friend one day was not the next. And I provided a rich attack surface for ridicule and whatnot, especially being Frack Magazine editor and somebody that enjoyed being front-facing. So back in those days, we had landline phones. Cell phones were sort of not really super popular yet, so we all had landlines. And one particular hacking group had compromised my local phone switch and rerouted all the phone calls to my house. And everyone who called my home was told that I had died of some socially communicable disease. So at the time, super distressing. Looking back 20 some odd years later, hilarious.
Still alive?
Still alive.
The thing with that story is that if you can tell people that it happened 2 weeks ago, but with modern tech, they would believe you, of course. Because it's just interesting how technology changes, but some of the modus operandi and ideas that people get don't change.
Mm-hmm. Sure.
That's at least maybe one lesson here, is that I should probably go easy on the 90s jokes because it happened in the 90s, could have happened in 2020s.
Absolutely.
You also wrote some really impressive books, which I admitted to Tim being very influenced by back in the early 2000s. And I think that the open source security tools, I think, is the one you wanted to mention, but there's also the Hackers Challenge books that were sort of like, in my mind, a very big deal and very impressive pieces of writing for that era.
Hyperbole aside, yes, I did write those books. Hackers Challenge 1 and 2, and I think I wrote the foreword for 3. And those just sort of provided these technical situations with enough detail for somebody to sleuth their way through to what the proper solution should be. They were fun. They were just fun books to write. For me, they were the entry price to get to be able to write a book I wanted to write, which was, as you mentioned, in 2000, the Building Open Source Network Security Tools book. And that was really on my own terms, and I really enjoyed that experience. And I got to sort of collect a lot of the open source projects and code that I had written, worked on, contributed to, and supported, sort of bring it all together and write a book about how to use these things to build tools to do useful things. One of those tools was actually a tool called Firewalk that a friend of mine at the time, still is, David Goldsmith, and I came up with this technique. And it was basically a way to enumerate firewall or packet filtering rules using conspicuous ICMP, basically trace route-like techniques. So fun stuff.
So I wanted to sort of transition or fly to today and sort of look at some of the current things that you're dealing with. And of course, to an extent you can share. So network security have changed in some ways, but it also hasn't changed in other ways. So given your experience, what are the biggest challenges facing network security today, based on your experience over the last large number of years?
I think what comes to mind, something that I deal with on the daily, which is complexity. If you look at the scale, like in 30 years ago, the Internet of Things has far less things. In the mid 90s, something like 16 million users. And today there's billions and billions of connected devices. There's huge demand for these things to run at scale and interact. And then there's the complexity involved with delivering the infrastructure and the at scale software in an always on fashion anywhere in the world, just about. And to accomplish this at scale, always on this requires a lot of complexity, especially in the networking space. And as all of us in the computer security world know, that complexity is this anti-pattern, is a breeding ground for vulnerability. And then I like to sort of think about this in the context of the explaining is losing maxim. So you've got this complexity anti-pattern that just is also often a second order effect of building complex distributed systems that evolve over time from hard-fought knowledge of what not to do. And you find yourself in these laden with tech debt. And, again, explaining is losing, right? If you have to sit down and deeply explain security features to customers and regulators and even employees why a particular feature is correct and why it needs to work the way it does, you run the risk of losing some credibility and, worst case, perhaps losing the audience. So one aspirational shining city on the hill goal that I will always march towards is to drive network security programs in the design phase using a principled approach, focusing on fundamentals and focusing on simplicity and letting designs somewhat speak for themselves.
This reminds me of Phil Venable's point about cloud, how simplicity needs to be deeply injected into everything, even when things seem complex around you, right?
Yeah, that's an anecdotal example that actually is top of mind when I reason about this network security complexity, the underside of the cloud, as it were. And then you've got no existential discussion about complexity or concerns of network security, be complete talking about threat actors, modern day threat actors. First started doing this, cyber network security, primary adversarial profiles were kind of smaller in archetypes and less concerning. The wily hacker, as it were, Clifford stole the cuckoo's egg and all of that. Sure, that was sort of the first example of a real threat actor that had worked with nation states, but this was in the 80s. More in the 90s and early aughts, you had script kiddies, as they were called, people that just sort of read various publications and tried to run canned exploits and hope for the best. And then, of course, you had insider risk with disgruntled insiders. But over time, this evolved into organized criminal gangs and nation state threat actors. And they both surfaced a significant threat, certainly to Google, but all modern organizations. But in different ways, I think. Generally speaking, if I understand this correctly when talking to my counterparts in the work on the detection response side, nation states certainly tend to employ more skilled actors, but they also tend to be less disruptive. So you think of silent persistence and stealing industrial and nation state secrets versus ransomware, denial of service for sort of immediate profit.
But if you're large, you're facing both. If you're a large org, a bank, a telco, cloud provider, you have both. You're on the radar of both types, like the noisy,
absolutely,
I'll destroy you for fun groups, and I'll get in without touching anything for profit. Well,
persistence.
To run off the metaphor, right?
Yeah. And then finally, I think talking about challenges facing network security is no more one size fits all. As table stakes for Google, we're a significant target, and we need to manage what is our ethos of organizing the world's information and making it available to the world. We manage as such. We take it very seriously. So we consider our fundamental network security primitives to be state of the art. with a number of defense in depth measures. Example, we were early adopter of zero trust and enforcing strong mutual authentication authorization for pretty much everything talks on the network, eschewing the traditional armadillo model of network security, hard perimeter, soft interior. But as we've grown cloud to service various entities, these days of where everyone just trusts Google to get it right, do the right thing, our tech island days of we do everything our own way, don't worry, we've got that. That argument doesn't hold as much water as it used to. Various customers, demanding customers and regulators have strong opinions and requirements about how we secure various pieces of the network. And different customers and different regulators are going to have different requirements.
Mike, could you say more about what you mean by tech island? I think that phrase has a lot of currency among certain technical folks at Google, but maybe not externally. And it's a very interesting concept.
So the tech island ostensibly is where, in order for Google to grow as it has over the last 20 some odd years, there was not technology available to do the things that needed to be done. So in many cases, Google pioneered that technology and built bespoke systems down to the hardware level in many cases that was just different from how industry was solving problems. And this served us clearly very well over the years. But as we march forward, especially with cloud, having our own proprietary protocols in some cases is not always going to be desirable, especially when we need to interoperate. So we need both. We certainly, our network security at scale internally runs different protocols than you would find elsewhere, but we still have a need to be able to do MTLS 1.3 and interact with other pieces of firmware and other customers that need to talk industry standard stuff. So just to close on the no more one size fits all, we find ourselves in a position where we have to evolve to adapt, to offer optionality or crypto agility, to present different cryptographic controls for network security, ostensibly based on customer compliance regime and what have you. So in a big part of cloud is based on shared infrastructure and makes this a challenging program to address over time.
So one of the things I commonly see with people who come to Google is they expected some of the challenges. They expected some of the issues. They expected some of the interesting projects. What has surprised you about being here?
A couple of things, I think. First, the sheer breadth and depth of the technical sprawl at Google. It's impossible, to say it's impossible to know all the things, like to be sort of a technical journeyman at Google is so much of an understatement. It's silly. There is just so much. So let's reduce that to a single problem domain. Even security at Google, and I work with a number of Googlers who've been working on Google security for more than a decade, in some cases two, and they don't know all the things. So just the breadth and depth of the sheer enormity of the technical infrastructure is one.
By the way, I've met somebody who said that if you think it's huge and you have a number in mind, it's actually larger than that. We're not really talking about the exact numbers. Some of us like me don't even know them, but I know that actually it's like much larger than what the largest number people had in mind when joining. I've heard that story from somebody.
Yeah, line goes up, basically. Like if you want to plot this as a line graph, like, and you pick your metric you want to instrument, like total number of, RPC calls per second or, bandwidth train. These numbers are astonishing. It's like thinking in terms of like Planck volume in the universe. Like these are numbers that are hard to reason about. It's not quite as big as Planck volume, but nevertheless, one of the things that sort of surprising challenges that is sort of perennial and will be one of these other sort of never quite good enough, always chasing is living at the intersection of performance and security. And we need both, quite simply. It's a ever-present challenge. We must act accordingly. Like if you look at like purpose-built hardware offload for computationally bound operations, yeah, Moore's law is diminishing. Now we're losing, this is going away. So we have to rely on clever engineering and economies of scale to achieve these wins. Because the demand for all these additional, let's just think of data in motion and cryptographic algorithms. Again, line goes up. So being able to do this at scale, as the scale increases, you just have to rely on ever increasing clever engineering combined with good use of the available hardware that you have.
And I think clever engineering, though, is something we can kind of take for granted here, because we do have the best of the best engineers on the planet doing this. I'm not mean in a boastful way, but when we talk to clients, sometimes we can't tell them do what we do, because some of the stuff we do is truly unique to just us. Like that's sort of good news, bad news, kind of, at least I sense it as that.
It's a tightrope, to walk sometimes.
Yeah, tightrope.
Yeah, for sure.
So let me briefly step away from the enormity of scale and ask something that's been actually kind of more of an Anton question, has been bugging me since the analyst days. And now that I have somebody who dealt with NetSec for so many years, maybe Mike knows. So periodically, and again, going back to my Gartner days, people would ask about network monitoring and sniffing traffic, and like, I want the packet capture, I want the details, I want the FPC, I want layer 7 decodes, and all this beautiful monitoring stuff. And then somebody else says, oh yeah, good stuff, but I also want encryption, I want it to be end-to-end, I want it to be from the starting device to the very end. It almost feels like this battle, or maybe battle is the wrong word, this competing requirements, security, occasionally privacy mixed in, between better encryption with better network security and threat detection has been maybe even longer than you've described. So how do you make sense of it? What do you tell people who want to say, I want to TLS everything, and then people say, yeah, I want to sniff everything?
Yeah, so people tend to have strong opinions, I think.
Yes.
There's certain there are entities that believe that security can be best applied by middleboxing, if you will, the encrypted traffic. In other words, proxying it, being able to introspect this encrypted traffic. And then ostensibly, then you are breaking sort of an implicit guarantee or agreement you have with the idea of having end-to-end encryption. And those folks tend to believe this is fundamental weakness. Writ large, as I understand it culturally, many Googlers fall in the latter half of this. And I believe that as far as my understanding of the technology is, that's how it's built. We do not proxy our end-to-end crypto for introspection. And we are in a wonderful position that writ large for most of our production fleet, we don't have to, because as we talked about before, we have a lot of bespoke infrastructure and we built a lot of these systems from the ground up. This gives us a good capability to design deep logging and instrumentation in such ways that might not be possible in other environments, so we can get the metrics that we need from this kind of logging while still maintaining that end-to-end guarantee of encrypted traffic.
So speaking of crypto, we have an upcoming episode that Anton and I both were initially skeptical about and then very excited about around post-quantum crypto. Could you give us like the 5-minute teaser version of this? Because I really want people to get stoked for our quantum episode, and I'm worried that they won't be.
We're not doing it just for self-promotional, podcast promotional reasons.
It's also an interesting area.
Yes, it's like genuinely confusing to a lot of people. Like, I want to go do post-quantum everything, but like then people say, why? It's not
here yet.
Really real for us. And it's like, it's been a head scratcher. And I've met enough people for whom it's also a major head scratcher. So I'm hoping that you'd have some magical answer.
I don't know if it's a magical answer, but I can certainly tell you my thoughts on the matter and maybe shed a little bit of light. It is really real. The concern about cryptographically relevant quantum computer, I think, as the government calls it. And that basically means a quantum computer that is capable enough to implement something called Shor's algorithm, which was designed in the 90s, this quantum algorithm for effectively rendering most modern public key cryptography irrelevant. So presumably this hasn't happened yet because cryptocurrency hasn't gone to zero. And the best estimates that we've heard from people that know about this stuff is, what year are we, 2024 almost, or maybe 2024, 5 to 10 years, something like that. So it's certainly something we care about. And so let's back up a little bit. Let's talk about it. What is, as they call PQC, post-quantum crypto, and as it relates to network security? The biggest threat here is the one of store now, decrypt later. And to level set, it's a long play attack where a threat actor captures a large amount of encrypted network traffic. And ostensibly, they're going to do their homework and try and capture traffic that would be long-term value, trade secrets, PII, or other information that has a long shelf life. And they save it. And they save it until they have, as I said, a cryptographically relevant quantum computer with enough qubits and error correction, or this butts up against my level of knowledge of how quantum computing works, to run Shor's algorithm. And to this end, the end of 2022, Google deployed a PQC safe, as they say, key encapsulation method to our internal RPC subsystem, externally known as ALTS. So since then, Google has been running a PQC safe algorithm such that if a threat actor were to start to store traffic, as far as current understanding goes, it is proof against cryptanalysis via Shor's algorithm. We deployed this algorithm called NTRU-HRSS, which is based off a heavily peer-reviewed lattice-based public key crypto system first introduced in the 90s. And the reason we chose this is because first choice was and continues to be a NIST standardized PQC standard, but it was still locked up in standards committees. We didn't want to wait, so we went with this. Since then, Kyber, as it's called, is the NIST and CNSA, which is the National Security Agency's National Security Algorithm Suite, which is basically the recommended set of crypto algorithms that organizations should use to be proof against current and future cryptanalysis. They recommend Kyber. Consequently, we intend to move to Kyber in 2024. Finally, I should note that the way it's deployed in a hybrid fashion, using classical elliptical curve key exchange alongside. So this just means that we get the benefits of both crypto systems. If PQC algorithm is shown to be insecure, we still can rely on the classical security for the time being, and vice versa.
So this makes sense, and I think that provides assurances for people who worry about this, but the store, it pretty much all screams top-shelf threat actors, right? Like the whole storing traffic for future analysis. So if this is the domain, if it's the expected domain of a top-shelf threat actors, is this really a concern for people who mostly worry about the classic traditional threat actors? We have to worry about this. I think you convinced me. But do others have to worry about this?
I suppose it depends on if you are a defense contractor, probably. If your organization is not transiting nation state secrets, probably not. The rub here is that a quantum computer, like we've talked about, currently doesn't exist as far as we know. And when it does exist, it's going to cost billions and billions of dollars. So it is the purview of nation states and wealthy nation states. So for now, no. But by the time we have Shor's algorithm as a GCP service or something like that people can leverage in the cloud, post-quantum safe or post-quantum secure key exchange protocols, I expect to be completely widely deployed and trusted.
That's a horrible thought. Shor's algorithm as a service. I don't like that.
Yeah, I know, right?
You gave me the depressing question award. I'll give you the depressing answer award.
I mean, I think people who've been doing predictions for something like, oh, it won't happen because it hasn't happened, are always right until they're wrong. Because there's this very particular moment when people say, next year, ha, 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 not going to happen. And it doesn't. And they look smart. But then they say it 5 times in a row, and then they look dumb because it actually does happen. And I think that's the story of our lives in technology. So I wanted to leave this aside and go not to the 90s and not even to the 80s, but kind of to the 60s-ish. And I want to ask a question about LLMs. No, LLMs weren't around in the 60s, but I'm hearing some interesting insights about this new technology of large language models and Gen AI, and it has something to do with Blueboxing. Kind of like, what's the story here?
Okay, so sure. So slightly out of my purview, but I think I know what you're talking about here.
I'm glad somebody knows what he's talking about there.
I guess this was the 1960s when people first started figuring out that they could make free phone calls using tone generators, or I guess as the colloquial story goes, the Captain Crunch whistle from the cereal box. And it generated this tone that if you blew the whistle, it generated a tone that would convince the switching system that you had paid for your phone calls. And the general problem here, the class of problems here, is that of in-band signaling, where you're shoving data and control information like key presses or payment, like when you put a coin in, and payphones. Who knows what payphones are anymore anyway? Yeah. If you have hair that looks like mine, you probably do, but anybody else may not. Those were phones that you had to use these strange circular coin-like money things, and you put them in the slot, and then you would be able to make phone calls. Anyhow, they shoved data and control messages down the same channel, and because of this, it enabled this sort of class of vulnerabilities. There have been these modern examples of these for years. SQL injections, another sort of similar example, commingling control and data. And hey, not to bring this back to something we talked about earlier, but the C-based buffer overflows of the past, present, and hopefully not future have a version of this as well. You know, you've got your string that you need to emit to a terminal somewhere. You have control characters in there too. Ostensibly, the null character or the lack thereof is another example of this. So anyway, bringing these back to LLMs, they too have one channel for data and control. And in modern computing...
Wait a second. Is it appropriate to all say,
I'm not even close to calling myself an expert or even a journeyman on AI or LLM-based chatbots, but what I have come to understand is it's a hard problem for them to solve due to the way they intermingle control characters alongside the data that a user enters. Apart from re-architecting to separate the control and data planes, as we've done elsewhere in modern computing, you think of the network with a control plane and data plane. This has been traditionally a hard class of problems to solve. Even with filtering and careful handling control characters and pattern matching and whatnot, you still it's almost combinatorially explosive, the space. I think one example that comes to mind of another problem area I spent a lot of time on is the idea of internationalized domain name homograph abuse. And that is taking Unicode characters that, for example, you have a Latin letter A and then you have a Cyrillic letter A. Right. They both look the same, but in the domain name system underneath, there are different characters, which would result to point to different domain names, but they visually fool the user. It's really hard to defensively register a given brand, such as Google.com, in such a way that you would prevent all of these homographic attacks. In that way, this is another hard problem to solve, that the attack surface is explosively large.
This means fun few years ahead, so we are kind of in the 1996 in this regard, right? From the Blueboxing LLMs for Fun and Profit paper is probably being written somewhere by somebody.
I think so. I've heard similar sentiment from people with regard to just LLMs in general. Like, we are at a massive sort of inflection point, as the internet was back in those days. And yeah, the abuse and misuse is going to be pretty incredible. My concerns around that stuff are primarily poisoning LLMs to give subtly incorrect information. And I'm sure that this is, again, the purview of nation states wishing to sway sentiment.
I think that one's really interesting because today it feels like LLMs give subtly incorrect information without any poisoning. So.
Yeah, right. It doesn't take too much.
Yeah, so I hate to do this, but it's time to wrap up. Do you have recommended reading, aside from, of course, the 1996 FRAC editions, and 2, a recommended piece of advice for people looking to up-level their network security game?
Sure. I just got a book I'm reading right now called The History of Disinformation on the Internet by Walter Shire. And it basically tracks exactly that. Starts before the hacking scene of the 90s, but it does cover hacking scene of the 90s, and it goes all the way up through more modern stuff, such as election fraud, and even talks about LLMs. Up-leveling your network security chops. I haven't reasoned about this in a while.
Well, encrypt everything, sniff everything, either of the two or both.
Worry about quantum.
Sure. All of those things still stand. I'm surprised at how much just knowing the fundamentals is still important. I guess I have 2 things to say here. Number one is it's still TCP/IP. At the end of the day, underneath the hood, it's still that. It's a lot faster. There's more of it. But understanding those fundamentals and knowing when to draw the line for abstraction, focusing on your problem domain is important. And sometimes you have to focus on, okay, I trust that this layer emits this kind of data or does this thing. I trust that a UDP-based connection is unreliable. I don't need to go deeper. Knowing where to draw the line of abstraction such that you can focus on the problem at hand to be able to attack it in a way to fully solve it, but also not going too far with the abstraction and making sure that you don't stop learning, because there's a lot of complexity out there. You can't learn all of it, but you do have to figure out where the boundary is.
That makes sense to me.
This is perfect. I want to make a very quick comment before we actually close, because I feel like this is a really interesting combination of learn some of the things that are very old, like TCP/IP, but also keep learning. It's also like the old basics matter, but the new stuff also matters. This is kind of what I'm hearing, and I think that's a very important side angle to this advice, is don't just keep learning the modern stuff. You need to learn some of the original stuff, like TCP/IP.
It really helps to understand. Yeah, you could spend your whole career just at the application layer and never understand the difference between TCP and UDP. But if you're a security practitioner or somebody that cares about that stuff, you're going to need to know it at some point.
Yeah, I agree with that advice wholeheartedly. Mike, can't thank you enough for joining us today.
Thank you both for having me.
And now we are at time. Thank you very much for listening and, of course, for subscribing. You can find this podcast at Google Podcasts, Apple Podcasts, Spotify, or wherever else you get your podcasts. Also, you can find us at our website, cloud.withgoogle.com/cloudsecurity/podcast. Please subscribe so that you don't miss episodes. You can follow us on Twitter, twitter.com/cloudsecpodcast. Your hosts are also on Twitter at Anton_Chuvakian and _Team Pico. Tweet at us, email us, argue with us, and if you like or hate what we hear, we can invite you to the next episode. See you on the next Cloud Security Podcast episode.